The illuminated LED moves left and right automatically. A light that moves right and left uninterruptedly and automatically is familiar to anyone. This is the configuration proposed in this experiment and can be used, for example, as a showy and eye-catching alarm simulator for the car. Functioning. An up-down counter with a variable frequency clock will be responsible for governing the decoder to whose outputs the LEDs are connected. The direction of movement of the LED that lights up is determined by the direction of the counter count, which is established by the logic level of the U/D input. This level changes automatically when the counter reaches the two extremes of 9 and 0 so that the LED will be moving continuously from one side to the other. The circuit. There are 4 clearly differentiated parts in the circuit: the clock, the counter, the decoder, and the logic for changing the direction of the LEDs. The circuit clock is carried out using the U3A port of the 4093. Potentiometer P1 allows us to vary the frequency of the oscillator and, therefore, the speed at which the LED moves. The oscillator signal is applied to the 4029 clock input, which is responsible for controlling the 4028 decoder. This integrated is what is directly responsible for attacking the 8 output LEDs, Q0 to Q7. Because there are precisely 8 and as outputs Q8 and Q9 are not connected, when these outputs are activated there will be a moment when they will all be turned off. As for the logic for changing direction, what you do is change the state of the counter's U/D input automatically via an RS bascule. When the counter reaches its maximum count, counting upwards, the CO output is activated at low level, which resets the weighbridge by setting the UD input to low level as 0, so that the counter starts counting downwards. When the counter reaches 0, the decoder's Q0 output is activated at a high level. Inverting this signal gives us the low level we need to set the weighbridge. This will place a high level A1 at the UD input, and the counter will begin counting upwards, repeating the process again uninterruptedly as long as there is supply voltage. Putting it into operation. The circuit with the power connected must work as explained previously. If this does not happen, we will turn off the power supply and check all circuit connections, paying special attention to the power supply to the integrated circuits. Experiment. If we find that the displacement speed is too fast, even with potentiometer P1 at its maximum value, we can reduce the speed by increasing the value of capacitor C1 or resistor R1, or both at the same time.